In the last clip, we saw the 6 rules that govern precipitation and dissolution. And probably watching this clip, you still haven't memorized the 6 rules. You still don't know why you need the 6 rules. And this clip will show you the kinds of deductions that you can make once you have absorbed the content of the rules. Okay, and there are really 2 types of problems that we can look at. We can identify if a compound is soluble or insoluble. So let's start off with AgI. Is this compound soluble or insoluble? And I put the rules down there so you can look at them and you can figure it out. So put in chat, soluble or insoluble. And so if you look at the problem, you'll see that silver, according to rule number 3. According to rule number 3, silver are insoluble. And then according to rule number 4, iodides are soluble. And so this problem is really going to turn out to be the battle of order of precedence. In this case, rule number 3 is the earlier rule, and therefore silver iodide is insoluble. This is how we use the rules. Let's look at another one. Let's look at barium CO3. So locate barium and locate carbonate and deduce whether this is carbonate and deduce whether this is soluble or insoluble. So give you some time to think about it. And it's rule number 5. The discussion of barium is again in rule number 5. And so we can see that carbonates are generally insoluble. And we can see that the discussion of barium in rules number 5 and 6 have nothing to do with carbonates. They're only about the hydroxides and the sulfates, and therefore we don't have to worry about the barium, just the carbonates. And the answer is barium carbonate is, put it in chat, insoluble. Let's just do, we'll do a pair together. CaSO4 versus MgSO4. These are both, Ca and Mg are both alkaline earths. Put in chat which of these two is the soluble one and which one is the insoluble one. Put it in chat. And which rule are we looking at? Put in chat which one is soluble of the two. First, I'll give you the answer. The soluble one of the two is the magnesium, and the insoluble one is the calcium. And they can be understood because if you look at rule number 6. So number 6 tells us sulfates are soluble with the exception of calcium sulfate, barium sulfate, and strontium sulfate. And so we can deduce then whether an ionic, a salt with a plus charge and a minus charge, anion and cation, whether a salt is soluble or insoluble. And that's the first level of deduction we can use making the rules. But the actual problems that you might probably see on the exam will go to the next step. And they're going to be, does the reaction occur? And we'll just do a few of these. We'll look at NH4. Here's the first one, NH4I aqueous, and HG ClO4 aqueous. And the question is there a reaction? And we're going to need the rules, so I'll put the rules down here in the next slide. And first, why is this aqueous? NH4, ammonium, according to rule number 1, are soluble. Iodine, rule number 4, they're soluble. this is soluble. It's definitely aqueous. And HgClO4, Hg1 plus are insoluble by rule number 3, but ClO4 by rule number 2 are soluble. That takes precedence. So both of these compounds are soluble. But when we put them together, is there a new combination of the two which is insoluble? And put in chat if there is a product which is insoluble, and put what that product is. And the answer is yes, there is an insoluble product, because we can go to HgI plus, so this reaction goes HgI plus NH4 ClO4, and Hg is, by rule number 3, is insoluble, while iodine by rule number 4 is soluble. And now the insoluble character of this has precedence, and therefore HgI is a solid. NH4 is rule number 1 is soluble. Perchlorate ClO4 rule number 2 is soluble. This is still aqueous, but that is a product. If you mix NH4I, which is dissolved in a liquid, and HgClO4, which is dissolved, you'll start seeing a precipitate, which is HgI. We'll do one more, and we'll do the hardest one, just to give you a feeling. The last one, NH4. This is a tricky one, but it's the kind of one that you could expect to see in a lot of Gen Chem exams all over the country. And so the question is there a product? And put in chat why this is a tricky problem. What is happening here that you need to also look out for at the same time? Can you see what it is? Let's see, what do you have in chat? The thing is, your first reaction is just to think about precipitation, but you have to look at these compounds more carefully. What is true about calcium hydroxide? That's right. It's a strong base. A strong base will react with any acid. And is there an acid on this side? And yes, NH4 plus is an acid. So if you put on the hat of thinking of this as a precipitation reaction, well, you're about to get the wrong answer, because this is actually an acid-base reaction. NH4 plus is the acid. It's going to go to NH3. NH3, and it will transfer the hydrogen to the OH minus, so it'll transfer to make H2O. And so 2 of these will react to make 2 of these, plus 2 waters, plus then there's going to be a calcium I2 by balancing. And is calcium I2 aqueous or a solid? And so iodides are in rule number 4. They have precedence over any mention of the 3 amigos in 5 or 6, and iodides are soluble, and therefore this is aqueous. Water is a liquid, and NH3, you can either put down gas or aqueous. Both, it really turns into both, and so there is a product, and these are the products. And notice I have balanced the reaction. So These problems are definitely require deduction, and you'll practice them this weekend in Pure Lead, and that'll be our presentation for precipitation and dissolution reactions.